my name is Aarya, and welcome to my presentation about plastic bags versus bioplastic bags, pros and cons. I decided to do this topic because I was really interested in biodegradable materials and whether we could save our planet using bioplastic. So I'm going to start with a simple project overview. This project is to determine whether a plastic bag or a bioplastic bag is stronger. The advantages of plastic bags are that they're easy to manufacture and they have established and widespread use. The disadvantages, though, include that they're not easily biodegradable and they pollute the environment. Also, to make plastics and plastic bags, you need hydrocarbons from fossil fuels. The advantages of bioplastic bags, on the other hand, are that they have minimal impact on the environment, and to create them, you only need natural materials. The disadvantages of the bioplastic bags are that they have limited applications compared to conventional plastic bags, and commercial production is still in early stages. This is my hypothesis. If bioplastic bags are stronger than conventional plastic bags, then bioplastic bags will become the overall better option because they are stronger for the consumer and good for the environment. Now, obviously, before I did my hypothesis, I had to do some background research. What is a plastic bag and what is it made of? Let's not get too complicated, but plastic is described as a material produced from oil by a chemical process which is used to make many objects. A plastic bag is just a thin sheet of plastic that is joined together to create a bag. On the other hand, we've got bioplastics. Bioplastic bags are a type of bag made from biodegradable materials, such as starch, cellulose, or polylactic acid, which is also known as PLA. So how does plastic decompose? As I said earlier, plastic can take a really long time to decompose. So other than their molecular structures, another thing that can affect its decomposition is sunlight exposure. Just like our skin, plastics absorb ultraviolet UV radiation from the sun, which helps break down their molecules. So this is why landfills often expose their waste to the sun to accelerate the breakdown process. So how does bioplastic bags decompose? Bioplastic bags are designed to be more environmentally friendly than traditional plastic bags because in the right setting, such as a moist and warm environment, they can decompose naturally. Finally, what tests will I be performing? After researching the different ways to test plastic and bioplastic bag strength, I found that the two easy and most favorable ways are the tensile test and the pressure test. In the interest of time, however, I chose only to do a tensile test. We will perform the tensile test using slotted masses and a hanger. By cutting strips out of our bag, then gradually adding weight to the strips, we can perform a tensile test. However, to perform an experiment, you must have variables. My manipulated variable will be the type of bag being used for each test, which is an LDPE plastic bag or an agar bioplastic bag. My responding or dependent variable will be the tensile strength of each bag. And finally, my controlled variable is the lab setting and the same piece of equipment for each test, which is a weight hanger or slotted masses, etc. This was my procedure. In the first step, I researched and organized my facts. Then, I made the bioplastic bags using an Amino Labs kit. I started by making 3 sheets, letting these sheets dry. I joined the sheets together then, and then I just let the sheets that were joined together, which became a bag, dry. So then I cut a template onto cardboard, and using that cardboard, cut strips off of the plastic and bioplastic bags. I also took measurements and so that we have accurate results. Then it was time to test. I used slotted masses and a weight hanger, and I took videos and noted down my observations. In steps 5, 6, 7, and 8, I analyzed my data using tables, which helped me determine my conclusions. I also wrote my report, and then it was time to present. So then I did my observations, and the next few slides will be all observation tables. So the table works like this. In the weight added column, I write how much weight we added and applied to the bag strips. And in the observations, I wrote how much tension I saw after applying that weight. So this is LDPE observation table number 1. This is LDPE observation table number 2. This is LDPE observation table number 3. And these are all the agar observations. 1, 2, and 3. So after analyzing all the tests 3 times, here are the final results. In LDPE trial 1, the strip tore within 1,210 grams of weight. In LDPE trial 2, the strip tore after adding 950 grams of weight. And in LDPE trial 3, the bag tore after adding 1,350 grams of weight. The average amount of weight necessary to tear an LDPE bag strip is 1,170 grams. In agar trial 1, though, we used only 150 grams of weight, and then the strip tore. In agar trial 2 and 3, we only used 50 grams of weight before the bag strip tore. The average amount of weight necessary to tear an agar bioplastic bag strip is 83 grams. We can conclude that my hypothesis was incorrect because it turns out that bioplastic bags are weaker than plastic bags. The LDPE average was 1,087 grams more than the agar average, and the objective of this experiment was to determine which material was stronger. A whole bag would have given us different results because a whole bag is a lot stronger than just a strip of a bag. Overall, while we may not have been able to put heavy things in biodegradable bags, we can still put lighter things like chips and popcorn bags. Throughout this experiment, I have learned a lot, and I can apply this knowledge to many other projects. Perhaps I could go deeper into this topic, finding ways to improve the strength of bioplastics and other biodegradable materials. All in all, bioplastic bags can be used to transport light but bulky goods like styrofoam, certain clothing, and even pillows. The potential sources of error in my project would have occurred during the procedure and testing steps. While creating the bioplastic bags, there may have been chemical residues from previous experiments, and this would be classified as chemical contamination. While testing the strength of these bags, there could have been equipment errors like faulty weights, incorrect scales, and incorrect shapes. And another phase of the testing could have incorrect measurements, and in that case would be a human error. These are my citations. I would like to thank Dr. Soares for being my mentor, Ms. Dawn for her support, Ms. Sarah for her lunchtime help, and Dr. Shaheen for her help as well. A special thanks to Sophia for helping me edit and revise my report. And finally, thank you to all other teachers, family, friends, and my parents for your continuous day-to-day support. Thank you so much for watching my presentation, and I hope that you found it interesting. Bye!